Hello friends, welcome back to Sapima tutorial. In our lesson today, we shall be considering the 2022 Neco Mathematics past question. We'll be considering the part A and the part B. That's about 12 questions in preparation for your Neco examination. The first question we have here says, given the square root of 3 equal to 1.73, rationalize correct two significant figures. So what we do is to rationalize this value first. When we have rationalized, we substitute. What we mean by rationalization, we use the denominator, which is irrational, to multiply up and down. This is how we rationalize. 5 times square root of 3 will give me 5 root 3 over square root of 3 times square root of 3. This will give me 3. The next thing we do is to substitute. So I'll say 5 times 1.73 over 3. Then you press your calculator. I have 8.65 over 3, and this will give me 2.883333333. And then remember, we are asked to leave it in two significant figures. So we are going to take the first two, but 8 is up to 5, so it will enter into 8. I'll now have 2.9. This becomes the answer. All right, the second question, we are asked to solve the quadratic equation using completing the square method. We have 3x squared minus 20 plus 12 equal to 0. To solve completing square method, the first thing we do is to use the coefficient of x squared to divide through all the terms here. This cancels this, so I'll have x squared minus 20 over 3x plus we have 4 equal to 0. The next thing is to carry the constants across the equality sign. So I'll have x squared minus 20 over 3x equal to minus 4. And at this point, take the coefficient of x, get the half of it, and square the half of it. So to do that, I'll get the coefficient of x, which is 20 over 3. To get the half of it, I'll multiply by 1 over 3. Now 20 times 1 will give me 20. 3 times 2 will give me 6. Then square this one, add it to the both sides of the equation. So to add, I'll have x squared minus 20 over 3x plus, I'll add this guy, we have to square it, 20 over 6 squared equal to minus 4 plus 20 over 6 squared. Alright, so at this point, the next thing we do is to factorize the left hand side. It's a perfect square expression this side, because here has a square, here has a square. So take the square root of this one, square root of this one, put in one bracket. I'll have x minus 20 over 6. The square root of 20 over 6 split over 2 is 20 over 6. Then square it outside equal to, let's expand here, this is minus 4 plus 400 over 36. Square of 20 is 400, square of 6 is 36. At this point, let's simplify the right hand side. The LCM I have here is 36. I'm adding here and here. 36 times minus 4 give me minus 144 plus this divide here is 1 times here. This is 400. Alright, then let's add and subtract. Then we add here, minus this plus 400 will give me 256 over 36. So this is what we have gotten for the right hand side. Then bring this one down. I have x minus 20 over 6 all squared. The next now is to eliminate the power by taking the square root of the both sides. So if I take the square root of here, then we add plus or minus here because it's a quadratic equation. So this square will cancel the square root. I'll have x minus 20 over 6. So we equal to plus or minus square root of 256 is 16 over square root of 36 is 6. All right. Something can divide there. 2 can divide to give me 8. 2 can divide to give me 3. So I'll have x minus 20 over 6 equal to plus or minus 8 over 3. So from here, actually, 2 can divide there to give me 3. 2 can divide there to give me 10. So let's carry 10 over 3 across the equality sign. So I'll have x to be equal to 10 over 3 plus or minus 8 over 3. We have a common denominator, so I'll be having x to be equal to 10 plus or minus 3 minus 8 over 3. Let's separate the signs here. So I'll have x to be equal to 10 plus 8 over 3 or 10 minus 8 over 3. Adding here, I'll have 18 over 3, or subtracting here, I'll have 2 over 3. Therefore, my x will be equal to 3 can divide 18 to give me 6, or we bring down 2 over 3. This becomes the solution to the number B. Okay, for the second question, a taxpayer is allowed 1/6 of his income tax-free, and he pays 20% on the remainder. If he pays 2,400, calculate his income and then tax-free amount. So we start by defining our parameter. Let x be the total income, all right? Then that man is allowed 1/6 of his total income tax-free. That is 1/6 of total income, which is x over 6. And he pays 20% on the remainder. How do we get the remainder? The total amount, we remove the 1/6. The 1/6, if I remove this one from total amount, I'll get the remainder. So that is x minus x over 6. This will give me 5x over 6. So this is his income tax-free amount, and this is the remainder, all right? Then the man pays 20% on the remainder. So we calculate 20% of 5x over 6. This is 20 over 100, 20%. And that amount is 2,400. He pays 20% of the remainder, which is 2,400. So equate it to 2,400. Let's simplify. 0 will cancel this 0. Then let 5 divide the 1. 5 divide 10, I will have 2. 2 divide itself 1. 2 divide 6, I will have 3. All right, so let's pick whatever we have remaining. I have x over 6 equal to 2,400. Then we cross multiply. 6 times 2,400 will give me 14,400. Now the total income of that man is 14,400. So we have gotten this first part. The next thing we do is to get his income tax-free. Remember that his income tax-free is x over 6, because we are told that it is 1/6 of his total income. Look at where we solved it. So to get this, we'll now say 14,400 divided by 6. When we divide it by 6, we are getting back this. So if his income tax-free is 2,400, and that becomes the solution. All right, straight to the third question. We are asked to find the value of P if the distance between these 2 points is 5. All right, these are 2 points of a straight line, and the distance is 5. So let's use the formula of distance between 2 points, which is x2 minus x1 plus y2 minus y1, all squared, all squared. All right, so let's substitute the values of x and y. Take note that the first one here is x1, and this is y1, x2, y2. So let's substitute. This is 5 minus x1 is p, all squared, plus y2 is 9. y2 is 9 minus y1, which is 5, all squared. But take note that our distance is giving us 5. So we'll write it here. To simplify, the first thing I'll do is to remove the square root because I can't find p with the square root. So I'll take the square of the both sides in order to eliminate the square root. So here square and here square. So I'll have 25 equal to the square will cancel the square root. So I'll have 5 minus p squared plus 9 minus 4 is 9 minus 5 is 4 squared. I'll have 16. Then let's expand this bracket. Expanding this bracket, I'll have 5 minus p and 5 minus p. 5 times 5 will give me 25. 5 times minus p will give me minus 5p. Minus p times 5 will give me minus 5p. Minus p times minus p is minus, okay, plus p squared. These two can add up to have minus 10p. So I'll have 25 minus 10p plus p squared. Bring 25 down. And then this 16, bring it down, plus 16. So at this point, you know that 25 can cancel 25 because if 25 crosses, it becomes negative 25. So 25 will subtract this. So I will have 0 equal to minus 10p plus p squared plus 16. Now arrange it, carry everything to the left hand side, but the signs will not change because we are just rearranging. So I'll have p squared minus 10p plus 16 equal to 0. So what we have is a quadratic equation which we'll solve. Now our product will be 16, which is the constant, and our sum will be minus 10, which is the coefficient of p. Now look out for two factors of 16 that you multiply to get 16. You add the same two factors, you have minus 10. They are none other than 8 and minus 2. Minus 8 times minus 2 will give me 16. Minus 8 plus minus 2 will give me minus 10. So put it here for minus 10. I'll have p squared minus 8p minus 2p plus 16 equal to 0. Then factorize. To factorize here, I'll group into two brackets. P is common here. Bring 1 outside. 1 remains here. Minus 8. Minus 2 is common here and here. So 2 will come out. I'll have p minus 8. Now take note that this bracket and this bracket must be the same at all times. Equal to 0. Then group the ones outside. This is p minus 2. Take one bracket. P minus 8 equal to 0. Then from here, we group, we equate p minus 2 to 0, and then p minus 8 to 0. To find the value of p from here, add minus positive 2 to the both sides in order to eliminate these two. So I'll say plus 2, plus 2. Then add positive 8 to eliminate negative 8. Plus 8, plus 8. 8 minus 8 will go, so my p will be equal to 8 here. This will minus here. My p will be equal to 2. So p is either 8 or 2, and that is the solution. So we go straight into question number B of that number 3. We are asked to find the angle between two lines whose slopes are 12 and 2 over 5. Okay, we use the formula tan theta equal to the absolute value of m1 minus m2 over 1 plus m1 m2. The first slope is m1, the second one is m2. Substitute it here. I will have tan theta to be equal to, my m1 is 12 minus 2 over 5 over 1 plus 12 into, that is times, m1 is 12 times 2 over 5, okay? We call absolute value. Then I'll have tan theta is equal to, let's solve the LCM of this. I'll have 60 minus 2, that is 5 times 12. You know how to solve your own fraction. So 5 times 12 will give me 60 over 5. Then here, 12 times 2 is 24 over 5. Then we simplify further. I'll have tan theta to be 58 over 5. Then simplifying here, 5 times 1 will give me 5 plus 24, which is, if I add here, I'll have 29 over 5. So bring it here. This is 29 over 5. So solving further, I'll have tan theta to be equal to, this is something as 58 over 5 times 5 over 29. To solve the division, change to multiplication and take the reciprocal of the divisor. It becomes 5 over 29 instead of 29 over 5. 5 can cancel 5, so I'll have tan theta to be equal to 29, and this guy can give us 2. 29 divide itself 1, 29 divide there 2. So we'll have the absolute value of 2. Then absolute value of a positive number is same thing as that number. If we have a negative number, it becomes positive. So to find theta, my theta is tan inverse of 2. That's how we get our theta. So my theta will be equal to, we punch the calculator here. This is 63.4349483. We can approximate it to one decimal place. We are not told to, but when we approximate, we define. Let's take to two decimal places. 63.43 degrees, 2 decimal places. Please, whenever you are not told to approximate, or whether you are told or not, whenever you approximate, define your approximation, because this could be 4 significant figures or whatever. So define it always. For question number 4, we are asked to find the matrix, the inverse of the matrix 3, 4, 5, 2. And we use the solution to solve these two equations simultaneously. Now, to solve the inverse of a matrix A, that is A inverse, we find the adjoint of A over the modulus of A. Now, to solve the determinant, that is the modulus, determinant of A first, 3, 4, 5, and 2. Then multiply 2 and 3. 3 times 2 will give me 6. Multiply 5 and 4 minus, this is 20. 6 minus 20 will give me minus 14. So my determinant is minus 14. Keep it. Let's solve the adjoint of A. To solve the adjoint of A, we rearrange the elements of the matrix 3 and 2 with interchange. Then take the additive inverse of 5 and 4. To do this, I'll have 2 and 3. 2 and 3 have interchanged. Then the additive inverse of 4 is minus 4, minus 5. This is adjoint. So put this as a fraction of 14. I will have my A inverse to be equal to 2 minus 4 minus 5 and 3 over negative 14. Use negative 14 to divide all 2. I will have my A inverse to be equal to minus 2 over 14, minus 4 over minus 14, minus 5 over minus 14, then 3 over minus 14. Let's break it down. My A inverse will become 2 divide itself 1, divide 14, 7. So I'll have minus 1 over 7. Then here, 2 can divide 2, 2 can divide 7. But minus and minus will cancel. So I'll have 2 over 7. Then this, nothing can divide, but minus and minus can cancel. I'll have 5 over 14. Here, nothing can divide. So I'll have minus 3 over 14. So this is my A inverse. So let's use it and solve the simultaneous equation. So I have 3x plus 4y to be equal to 1. And then 5x plus 2y to be equal to 3. Arrange the coefficients of the variables in a matrix equated to this also. I'll have 3 and 5, 4 and 2. Then multiply it against the variable. x and y equal to this. This is a column matrix. Now to solve for x and y, let's call this A, B, and C. To solve for B, this guy, we have to move over this side. Then you have to come over this side. So we divide both sides by A. I'll have my B to be equal to C over A. So this is same thing as B equal to C times 1 over A. And 1 over A is same thing as A inverse. So to get my B, which is these variables x and y, I'll use C and multiply A inverse. But remember that we have gotten A inverse as this guy, and our C is this one, okay? So multiply this and this. Solving for B, my C is 1 over 1 and 3. 1 and 3. And then my A inverse is this guy. So I'll bring it here. Minus 1 over 7, 5 over 14. I have 2 over 7 minus 3 over 14. This is it. So to multiply, we multiply column against row. So 1 we multiply here plus 3 we multiply here. We come over here also. 1 we multiply here plus 3 we multiply here. So let's go. So 1 times here, this is 1 times minus 1 over 7. Then 3 times here, 3 times 2 over 7. Then the same thing will happen here. Remember, we are adding 1 times here, 1 times 5 over 14 plus 3 will multiply this. 3 times minus 3 over 14. 1 times minus 1, this will give me minus 1 over 7 plus 3 times 2 will give me 6 over 7. 1 times 5, I'll have 5 over 14 plus 3 times minus 3 is minus 9 over 14. Then let's add. 7 is common denominator, so I'll take 1. Minus 1 plus 6 will give me 5. 14 is common denominator, 14. 5 minus 9 is minus 4. Can it break down? 2 can divide here and divide here. This is 2 and 7. So my final answer, B, which is equal to x and y, is 5 over 7 and 2 minus 2 over 7. This becomes the solution of this simultaneous equation. You can solve it normal using elimination or substitution method and see if you will arrive at this solution. You are asked to solve this circle, giving O as the center of the circle, and then AB to be equal to BC, CD, AB equal to CD, okay? And the COD, angle COD, COD 85. Find these angles. Now to simplify, we look out for the first possible angle we can get. For me, the angle facing here is the first angle I can get, AOB. So I is AOB, which is equal to COD, COD, angle COD, and it is 85 degrees. Now the reason is vertically opposite angles. Vertically opposite angles are equal. So here is equal to here. So angle AOB will be equal to 85 degrees. Then we check for the next possible angle to get. This place is the next possible angle. I can use here to get it. Observe this straight line. Part of the straight line has been gotten, remaining this side. So if I remove 85 from 180, I will get this side. So that is BOD, BOD, the fourth one. It must not follow the order of arrangement. You can get anyone at a time. So to get this, BOD, angle at BOD will be gotten by 180 subtracting 85 degrees. This is angle on a straight line. So if I subtract, then my BOD will be equal to 95 degrees. So the angle here is 95 degrees. Then we check for the next possible angle, which is this. This angle is an angle formed at the circumference, which took its origin from here. All right? So it is half of the angle formed there. Remember that the angle formed at the center of the circle is twice the angle formed at the circumference. So the both of them took their origin here. This went up and this came this way. So the angle here is twice the angle here. That means the angle here is half of this. So I will say that that is BCD. Let's get it, BCD, the second one. So BCD, angle BCD is equal to half of this one, BOD. Okay. That is angle at the center and the circumference. So this is BCD will be giving me half of, this is 95. Remember, we have gotten here as 95 degrees, which is 47.5 degrees. So my BCD, angle BCD, because it will be 47.5 degrees. Let's look out for the next possible angle to get. I've gotten the angle here as 47.5 degrees. So we can get here BAD. Look at this, BAD, To get my BAD, take note that BAD is equal to BCD. Now the reason is because they are in the same segment. They are in the same segment. So my angle BAD is equal to 47.5 degrees also. And finally, we are looking for OBD. All right, angle OBD, which is the angle OBD at this position. So to get this angle, recall that we have gotten here as 47.5, and the angle here is 90 degrees. How do I know? This is the center of the circle. If a line passes through the center of the circle, the angle produced at the circumference is a right angle. So the angle here is right angle, which is equal to 90 degrees. So add this and this, subtract from 180 degrees, you get here. So we say that this is 180 minus 47.5 plus 90 degrees. And our reason is sum of angles in a triangle. Sum of angles in a triangle. So adding here, this is 180 minus 137.5. Okay, subtract, we'll have 42.5. So the angle OBD is equal to 42.5. All right, so we've gotten all the required angles, and you have seen the steps to which we follow to get it. We want to continue in this tutorial with number 6 of the Neco 2022 class question. All right, so we are asked to use logarithm table to simplify. We have a square root over the value we want to simplify. So the first thing I will do is to remove the cube roots. So to remove the cube roots, I will write this thing again, take the power of a fraction of 1 over 3. So I will have 565 times 0.0536 over 249.1 raised to the power of 2. And then I'll raise everything again to the power of 1 over 3. 1 over 3. This is because I have a cube root. If what I have is a square root, I'll take the power of 1 over 2. If what I have is fourth root, power of 1 over 4. So the next thing we do is to solve. I'll write my number here. This place will be my logarithm number. So we start with 565. The first thing I'll do is to take my characteristic, which is 2. 1, 2. My characteristic is 2. So I'll check for 56 under 5 from my logarithm table, which is 7520. I'm done with this. I'll go over here. I have 0.0536. To get my characteristic, because I have a 0 starting, my characteristic will be gotten from here. I'll count zeros until I've counted a non-zero digit before I will stop. So I counted 2 times, therefore I'll have bar 2. Then I'll check for 53 under 6 from my logarithm table, which is 7292. We are multiplying this value, multiplying this value, so you add. Remember, in logarithm, whenever you have a times b, we can change it into log a plus log b. The same thing happens here. Since we have multiplication, we add. 0 plus 2, this is 2, add here 11, carry 1, put here 6 plus 2, this is 8, add here we have 14, I'll put 1 here, 3 plus minus 2, this is 3 plus minus 2, which will give me 1, so I have 1 here. Then we'll keep this, solve the denominator. I have 249.1. To solve this, we get the characteristic first. We count from the point to the left because it's a number greater than 1. I have 2. Then we'll check for 24 under 9, difference of 1. We use the logarithm table, and that will give us 3964. Remember that this value is divided by this one. So when you have division, you subtract. When you have division, if A is divided by B, then we are subtracting the 2 logarithms. So let's subtract. 2 cannot minus 4, so we borrow 1 from here. This is now 0. This is 12 minus 4. I will have 8. This is 0. Borrow 1 from here. Add here 10 minus 6. This is 4. Here is 7. We borrow 1 from here. Add here. We have 17 minus 9. That is 8. 3 minus 3. This is 0. Then 1 minus 2 give me minus 1. So we call it bar 1. At this point, remember your power of 2 and then power of 1 over 3. Let's handle power of 1 of 2 first. We multiply. Whenever you have a whole number as your power, use it and multiply. So we multiply here. If we use 2 and multiply, we'll have bar 2.1696, okay, from this multiplication. Then the next thing we do is to handle the 1 over 3 here. To handle that 1 over 3, we will divide by 3. Anytime you have a fraction here, 1 over any number, use that number and divide. But because we have a bar, a negative number, we are not going to divide straight. Look for a number that this divisor can divide without remainder, which is 3. Add the bar. What number can I add to this bar 3 to give me back bar 2? That is a positive 1. 1 plus negative 3 will give me negative 2. Bring down this number, 1696. Then we divide. So at this point, 3 can divide negative 3 to give me negative 1. That is bar 1 plus. Use calculator and press this one now. This guy divided by 3. It will give me 0.3899. Then we bring them together. I'll have bar 1.3899. So at this point, we check for the anti-logarithm, which is the solution we are looking for, anti-log. We use our logarithm table to check for 38 under 9, difference of 9. Forget about this one for now. I'll tell you what to do with it. So if we check for 38 under 9, difference of 9, we'll have 2454 from the logarithm table. You already know how to read it from the logarithm table. Anytime you have a negative number as your characteristic here, add that number of zeros here. If I have bar 2, I'll add 2 zeros. If I have bar 3, I'll add 3 zeros. So since I have bar 1, I'll add 1 0 in the front and put a point. All right? If you're asked to convert this number to a standard form now, you are going to move 1 decimal place like this once, and then you say your power is minus 1. So that's how we got this this 0 here. All right? So our answer, the number we are looking for, is 0.2454. You can press your calculator and see if you get something similar or very close to this number. It may not be exactly this number, but to give you a number close to it. We have another interesting question, the B part of that number 6. An arc AB subtends an angle of 36 degrees at the center of the circle of radius 7 cm. Calculate the area of the minor sector. So the first thing we do is to generate the circle we are talking about. All right, so let's assume you have this circle and a chord producing an angle, subtending an angle to the center of the circle, and that angle is 36 degrees. This is the radius. Remember that this chord is AB, and then the radius is 7 cm. You can add 7 cm here. Then we solve for the area of the minor sector. The minor sector is the area represented by this. So the formula we are using is theta over 360 times pi r squared. Let's substitute. This is 36 degrees over 360. That's my angle. Times, we are asked to use pi as 22 over 7. Please take note of that. It was included in the equation. If you are not told to use pi as 22 over 7, use 22 over 7 constantly, except when you are told to use 3.142 times 7, our radius is 7 raised to the power of 2. 36 divided by 360, this is 10, and this is 1, so 1 over 10. 7 is 2 here, so 1 will cancel 1 here. I will have 22 times 7 over 10. Then point your calculator at this point. 22 times 7 divided by 10, this will give you 15.4, and then the unit is cm squared, the area of the sector of a circle. So let's solve the number 7th question. We are asked to solve the AP given the sequence and find the 99th time and the nth term. Okay, take note that the formula for an AP, the term of an AP, is A plus n minus 1 common difference. So to get the 99th term, we are solving for t99. The first term of this equation, of this sequence, is 6. So I'll put 6 here. And my n is the number of terms I am looking for, which is 99 minus 1. My common difference is 3. If I add 3 to 6, I'll get 9. Add 3 to 9, I'll get 12. Add 3 here, add 3 here, you get 18. So my common difference, D, is 3. Put it outside there. Then we solve. This is 6 plus 99 minus 1 is 98. So I'll have 98 times 3. So we point multiplication first. 98 times 3, this will give me 294. We add it to 6, we'll have 300. So my T99 is equal to 300. Then the next thing we are asked to get is our nth term. Our nth term, that means our answer will be in terms of n, okay? So we just substitute. The first term is T6 plus our n, we don't know, that is what we are looking for, the nth term. Then our common difference is 3. We operate 6, okay, 6 plus, open bracket, 3 times n, this is 3n, 3 times 1, this is minus 3. We are looking for nth term. So 6 minus 3 will give me 3. 6 minus 3 will give me 3. All right, so my nth term is given by 3n plus 3. So with this formula now, you can get any term of the given sequence or any term of the sequence you are looking for. This given sequence, you can get the 20th term of the sequence using your nth term, or you can use your formula direct and solve it. This is question number 7b. Differentiate square root of 1 minus x cubed. So let's solve. I have y to be equal to square root of 1 minus x cubed. Let's unbox this square root. Y is equal to 1 minus x raised to the power 3 raised to the power 1 over 2. So we have a chain rule, a function of a function. we'll be making use of chain rule to solve it. The y over the x is equal to the y over the u, differentiating y with respect to u, times the u over the x. Okay, so that means we need u in this our expression or function. What is our u? We say let u be equal to the function inside the bracket, which is 1 minus x raised to the power 3. That means that my y will now be u raised to the power 1 over 2. Since we say that u is now the function inside the bracket, this bracket now, that means that bracket, which is now u, is raised to the power 1 over 2. Then let's differentiate. Differentiate u with respect to x. That is this function. If I differentiate a constant, I will have 0. If I differentiate x raised to the power 3, I will have 3x raised to the power 2. Because 3 minus 1 will give me 2. You recall how we differentiate. So the next thing we'll do is to differentiate the second function, the u over the y over the u. Differentiating here, the power will come down. I'll have 1 over 2u. Then 1/2 minus 1 will give me minus 1 over 2. Yeah, half minus 1 is minus half. Then multiply the two functions. Look at this. The first one multiply the second one. So I'll say 3x squared multiplying 1 over 2u raised to the power minus 1 over 2. Then if we multiply, I'll have 3x squared over 2. 3x squared times 1 give me this, u raised to the power minus 1 over 2. Then let us recall that u is equal to 1 minus x raised to the power 3. So let's bring it back here. That means I'll have 3x squared over 2 in a bracket 1 minus x raised to the power 3. And then remember we have this guy minus 1 over 2. We will not leave it here. Let's handle this power, this negative power. That means what I will have now is 3x squared over 2, 1 over the square root, 1 over the square root of 1 minus x raised to the power 3. We can still break it down as 3x squared over 2 square root of 1 minus x raised to the power 3. This is the appropriate answer. What happened there is that this is a coefficient of a fraction. So the numerator will multiply this one to give us this. And whenever you have a negative as your power, you can take the 1 over the function you have. Look at this. Because of this negative, you take 1 over this same guy. Then because of this 1 over 2, we are taking the square root of this function alone. Remember that this one is not inclusive. It's just about this one. That is how we got to this stage. All right, C question says, a curve passes through the points and its gradient at any point is given by this function. Find the equation of the curve. So we are looking for this equation of the curve that passes through this point and we are given this gradient. So anytime you are given a gradient and you are looking for the equation of the curve, integrate. So we are going to integrate this now. So since this is a gradient, it is the derivative of a curve. Therefore, we say the y over the x is equal to 6x squared plus 10x minus 7, since it is a derivative. So what we do is to integrate the both sides to get the equation of the curve. If I integrate the y over the x, I will have y equal to, integrating here, if I have ax raised to the power n and I want to integrate, n will come down and multiply a, then n will add 1 and come down as my denominator. This power will come down as my denominator. Let's do that here. 2 will come down and multiply 6. I'll have 12. Then 2 will add 1. I'll have 3. It will still come down as my denominator, right? Same thing here. The power of x here is 1. So 1 times 10 is 10. And 1 plus 1 will give me 2. Will give me 2. So I'll have raised to the power 2 over 2 minus, integrate a constant you have the variable of that function. So if I integrate 7, I'll have x attached to it or added to it. Then we'll add our constant. Let's use c. We can use c, we can use k. So this is the equation of the curve. We can reduce it. 3 divided 12 will give me 4. 2 divided 10, I'll have 5. And then 7x plus c. All right, so to get this c, substitute these 2 points in this equation. We get our c and bring it back. So my y is 2 equal to, this is 2. I'll have 4 into minus 3 raised to power 3 plus 5 into minus 3 raised to power 2 minus 7 into minus 3 plus c. Okay, at this point we expand. I'll have 2 equal to minus 3 raised to power 3 is minus 27. Minus 27 times 4 will give me minus 108 plus minus 3 raised to power 2 is positive 9. 9 times 5 will give me 45. Minus 7 times minus 3 will give me plus 21 plus c. So if we add and subtract here, I will have c to be equal to minus 44. So since we have gotten c as minus 44, let's bring it back into this equation. So the equation of the curve we are looking for is 4x raised to power 3 plus 5x squared minus 7x minus 44. And this is the solution. Question number 8a. X and y are the surface area and volume of a sphere respectively. So x, the area, y, the volume. And we are given that x over y is 2 over 7. Find the values of x and y. So how do we go about this now? X is the area of a sphere, which is 4 pi r squared, and y is the volume of a sphere, which is 4 over 3 pi r cubed. All right, so to get the value of y, of x and y, I need to get my r to substitute here. As soon as I've done that, I'll get x and y. So to get the value of r, we'll use this function here, this relation, which is x over y is equal to 2 over 7. We can cross multiply here. I will have 7x equal to 2y. Let's go back to this equation. You can call it equation 1 and 2. So substitute equation 1 and 2 into here for x and y. So I'll have 7 into 4 pi r squared equal to 2 into 4 over 3 pi r cubed. So let's eliminate this 3, which is a fraction here, and multiply 2 against 4. We'll have 7 into 4 pi r squared equal to 2 times 4 is 8 over 3 pi r cubed. Then multiply both sides by 1 over 3, so that this, no, by 3, so that we eliminate this 3 here. All right, so 3 will cancel 3. 3 times 7 will give me 21. 4 pi r squared equal to, I have 8 pi r cubed. Remember that what we are looking for is r. We are looking for r. So since I have pi here, both of them can cancel. I have r cubed here and r squared here, so I'll have r remaining. Let's bring out the other things that we have. 21 times 4 will give me 84 equal to 8r. Then divide both sides by 8. My r will be equal to 10.5. So having gotten my r as 10.5, the next thing I'll do is to substitute 10.5 into this relation. I'll get my x and y. So how do we get x? X is 4 times, remember that pi is 22 over 7. 22 over 7 times my r, 10.5 squared. All right, so let's simplify. 10.5 squared will give me 110.25. 4 times 22, I'll have 88. over 7. If you point your calculator here, we are going to be having x to be equal to 1386, right? And this is in cm squared because it is the area of a sphere. Then for y, I will have 4 over 3 times 22 over 7 times 10.5 raised to the power of 3. Point your calculator. If you point your calculator very well, you'll have y to be equal to 462 in cm cube because it is the volume. So we've been able to get the value of x as this and the value of y as this. Question number 8b. Find the equation and x-intercept of a line which is perpendicular to the line 3x plus 3y equal to 5 and it passes through the point 3, 2. All right. Whenever a line is perpendicular to the other line, then the slope of that line, say m1, is equal to minus 1 over the slope of the second line. Vice versa, m2 is equal to minus 1 over m1. So what we are going to do is to find the slope of this line. When we get the slope of this line, we use it to find the slope of the second line. And hence we have found the slope of the second line. We use these 2 points and get the equation of that line. So let's go. I have 3x plus 3y to be equal to 5. To get the slope of this line, I will write it in slope-intercept form. That means making y the subject formula. This 3y equal to 5 minus 3x. Then I'll divide through by 3, which is the coefficient of y here. So y is equal to 5 over 3 minus x, because 3 will divide 3 to give me 1. Now, the slope of this equation is the coefficient of x, and the coefficient of x here is minus 1, the coefficient of x. So I've gotten the slope of the first line. Let's call it m1. Since we have gotten m1, let's substitute minus 1 into this equation to get our m2, which is the slope of the second line we are looking for. So m2 is equal to minus 1 over minus 1. That means my m2 will be equal to 1. I've gotten the slope as 1. But meanwhile, the equation of a line says that y is equal to mx plus c. So let's substitute the values of m, the value of x, and then the value of y. We'll get c and bring it back here into the equation. So the value of y here is 2 and x is 3. So I'll have 2 to be equal to, my slope is 1 times x, which is 3, plus c. Here will give me 2 is equal to 3 plus c. Then, making this guy the subject, 3 will cross. I'll have 2 minus 3 equal to c. That means my c is equal to a negative 1. So I'll carry it back into this equation. This is y equal to, my slope is 1. So I'll have 1 times x plus my c is negative 1. It's negative 1. So the equation we are looking for is y equal to x minus 1. Then let's rearrange it and make x and y to be on the left hand side, including the constant if you wish. So I'll be having y minus x equal to minus 1. So this is the new line which is perpendicular to the given line. One other thing we are going to do is to find the x-intercept. We are asked to find the x-intercept. So to find the x-intercept using this same equation, or we can use this, we record that we get the x-intercept at y equal to 0. So substitute it here. That means 0 is equal to x minus 1. Make x the subject. That means 1 will cross over. 1 equal to x. That means my x-intercept is 1. So let's go straight into question number 9a. We are asked to make m the subject formula in this relation. So we have m here and we have m here. All we have to do here is to make m come out and stay alone, not inside again. The first thing I will do is to multiply both sides by a square to eliminate the square root. All right. The square will cancel the square root. So m is equal to n minus m square f plus 1 all over d minus n. This is m squared. Okay. So let's cross multiply in order to deal with the fraction. I'll have m squared equal to d minus n equal to n minus m square f plus 1. So having done that, let's carry this m square across to meet the border. I'll have this plus m square f equal to, we have this and this, n plus 1. Then let's factorize. We have m square here, we have m square here. 1 can come outside. Then we have d minus n, and f is still here, plus f. All right, equal to n plus 1. To get m squared, divide both sides by the coefficient of m squared. I'll have m squared into d minus n plus f equal to n plus 1 divided by d minus n plus f over d minus n plus f. This guy will cancel this guy, so my m will be equal to n plus 1 over d minus n plus f. Okay, remember we have square here. So to get m, which is what we are looking for, we take the square roots of the both sides, so that square will cancel square roots. I will have m to be equal to n plus 1 over d minus n plus f on the square root. So we've been able to get m as the subject of the formula. But recall that we are asked to evaluate m given the values of the variables we have here. So we simply substitute. My m will be equal to square root of, my n is 3, okay, minus plus 1 over, my d is 8, minus n, which is 3, plus f. My f is 4. All right, let's evaluate. M will be equal to 4 over 8 minus 3 will give me 5 plus 9, 4. We have 9. The square root of 4 is 2. The square root of 9 is 3. So we have my m to be equal to 2 over 3. Let's go straight to the b part of that number 9. To solve 9b, r varies inversely as the cube of s. R varies inversely as the cube of s, that is s raised to power 3. R is 8, s is 4. Find s when r is this, okay? So the first thing we'll find is the equation of the relation. This is r equal to k over s raised to power 3. So we need to find k to form the equation of the relation. When we have done that, we can get s when r is this. So to do that, remember that r is 8. So I'll have 8 to be equal to k over my s is 4. 4 raised to power 3. All right, so we'll have 8 equal to 4 raised to power 3 will give me 64. So k is this. Then we'll multiply, cross multiply to get k. If I cross multiply, I'll have my k to be equal to 8 times 64. 512. Having gotten k, the equation of the relation becomes r equal to 512 over s raised to power 3. Even though we are not told to get it, but if you're asked to get the equation connecting s and r, when you have gotten your k, you do this. This is equation connecting s and r. All right, so to find s when r is 512, simply substitute our r as 512. So r is 512 over 216 equal to 512 over s raised to power 3. Then, since we have this numerator and this numerator to be the same, both of them can divide or cancel. We now have s power 3 equal to 216. At this point, take the cube root of this side and cube root of this side. So the cube root of 216 will give me s to be equal to 6. 6 is a number you multiply 3 times in order to get 216. So we've been able to get the value of x given r as this. Let's solve question number 9c. So for question number 9c, we are asked to find the derivative of this. So we are going to differentiate. This is y equal to cube root. This is cube root. Let me write it well. Cube root of x raised to power 4. So let's deal with the cube root first. We have y to be equal to x raised to power 4 times 1 over 3. Cube root means power of 1 over 3. That means my y is equal to x raised to power 4 over 3. 4 times 1 give us 4, then over 3. Then we differentiate the y with respect to the x. The power will come down first. I will have 4 over 3. Then the power will remove 1. That is 4 over 3 minus 1. So I will have 4 over 3 x. Then 4 over 3 minus 1 will give me 1 over 3. So we can still represent this as a square root. So my dy over the x will be equal to 4 over 3 cube root of x. You know that 1 over 3 is a cube root, so it takes care of x alone. So you can leave it like this, or you can still write it as 4 cube root of x over 3. This is denominator, so this whole can multiply this to come together. So we leave it as this. A composite solid consists of a cone on a top of a cylinder. The cone is 8 cm high and the slant height is 10 cm. If the solid is 18 centimeter high, calculate the volume correct to two significant figures. So the first thing we do is to draw the diagram involved. All right, so we have a cylinder first. We have a cylinder and then a cone sitting on top of this cylinder. And we are told that the height of the cylinder is 8 cm. I mean the cone rather is 8 cm. And the slant height, that is this, here is 10 cm. But meanwhile, the total height from here to here, so let's draw this out. The total height from here to here is 18 cm. And we are asked to find the volume of this diagram. So our assignment is very simple. Find the volume of the cone, find the volume of the cylinder, then add them together, okay? But meanwhile, to find the volume of this guy, we need the radius. We need the radius, r. So to find the r, we can actually use this guy, this right angle here, is a right angle, to find this side, which is the radius, okay? So let's find the radius. We use Pythagoras theorem. This Pythagoras theorem, h squared equal to a squared plus o squared. My h is the slant height, which is 10 squared, equal to, this is my adjacent, so I have my o, which is 8 raised to power this. So I am looking for a, which is actually my r. So to get a from here, we square 10. This is 100 minus 64. 100 minus 64. You know that this guy will cross over to meet 10. So rearranging it, will have something like this. Then when we subtract, my a will be 36. Sorry, this is a squared. Then taking the square root of the both sides, I will have my a, which is my radius, to be equal to 6. So I've gotten here as 6. The next thing we need to do is to get the height of this cylinder, the height from here down here. Since we have the total length of this shape from here to here as 18, but take note that from here to here is 8 centimeter. That means the remaining part will be 10. So here is 10. From here to here, 18. Here is 8. This is 10. So having gotten all the parameters that we need, the next thing we do is use the volume of the cone and the volume of the cylinder. Add them together to get the volume of the composite shape. So we say volume is equal to that of the cone is 1/3 pi r square h plus that of the cylinder, which is pi r square h. Then we substitute. V is equal to 1/3 times 22/7 times my r is 6. So I'll have 6 raised to the power 2 times my height, which is 8, plus I have pi 22/7 times my r 6 squared times the h, the height, which is 10. It is 10 here. If I point this, and this, I'll have 6 over 3 times 7 is 21, plus, then we point here, 22 times 6 squared, which is 36 here, times this. I will have 7920 over 7. Then we add. Point your calculator very well. You have V to be equal to 1433.142857. Then remember that we are asked to take the first two significant figures, which is 1 and 4. So our volume will be equal to 1400, 1400 centimeter cube. We are measuring the volume, which is measured in centimeter cube. So this is the solution to number 10 question. So let's solve question number 11. We are given a function and we are asked to copy and complete this table. So the first thing you will do is to copy this table into your workspace. Please don't use this one they gave you in the equation to solve. It has its mark if you copy it down to your working space. But allow me to use this table now in the equation because I don't have enough space. So let's substitute the values of x to get the corresponding values of y using this equation. 3 has been solved. I will solve for -2. So I have y to be equal to 6 plus 3 into -2 minus 3 into -2 squared. -2 squared is 4 times -3, I have -12. 3 times -2 will give me -6. Then we bring down 6. 6 minus 6 is 0. So my y will be equal to -12. Here is -12. See exactly what I've done here. Please do it here, here, and here. Put 2 and solve. Put 3 and solve. You will get here as 0. You get here as -12 and get here as -30. All right, so let's proceed to solve the graph. We are asked to plot the graph of the relation, this function that was given to us, using the scale 2 cm to represent 1 unit, and then 2 cm to represent 5 units on the y-axis. This one is for the x-axis. Let's plot the graph. We are going to use 2 cm to 1 unit on the x-axis. So this is my x-axis. We are using 1 unit. So this is 1 unit, 2, 3, and 4. And then here we will have -1, -2, -3, and then -4. Okay, 1 unit means we are counting in 1. All right, then 2 cm. For my graph, we have from here to here as 2 cm, from here to here as 2 cm. Some graphs will give you from here to here as 1 cm. All you need to do is to count the number of little lines. If you have 10 little lines in between thick lines, then it is 2 cm. If you have 5 little lines in between the thick lines, it is 1 cm graph. So from here, which is the origin 0, from here to here is 2 cm, 2 cm, 2 cm. The same thing happens here. So on this part, I'll have here as 5, 10, 15, 20, 25, and then 30. Then here I'll have -5, -10, -15, this is 20, -25, then -30. Then we plot. To plot the graph, we'll construct or plot the x-axis against the y-axis. The first is -3 and -30. -3 for x, -30 for y. They will meet at this point. The next is -2 and -12. This is -2. To get -12, -12 will be in between 10 and 15. But we are going to count the little lines. How do we know how to count the little lines? The interval or the scale is 5. So we'll say 5 over the number of little lines here. If I divide, I'll have 0.5. So each little line is 0.5. Since I have 10 here, this is 10.5, 11, 11.5, 12, 12.5. So 12.5 is somewhere here. But we are looking for 12 rather. So 12 will be somewhere here. So 12 and 2 will meet at this point. Then the next we have is -1 against 0. So we'll plot it on the -1 intercept. Next we have 0 for x and 6 for y. 0 for x, 6 for y. We'll count, this is 5, 5.5, 6. So 6 will be somewhere here. They will plot it on the 6 intercepts. Then the next we'll have is 1 against 6. So 1 for x and 6 for y. So it will be here. Then the next we have 2 for x and 0 for y. This is 0 for y, 2 for x. Then we have 3 and -12. This is 3 for x, -12. You have gotten -12 to be somewhere here. Make the asterisk. And then we have 4 against -30. This is 4, and -30 is down here. All right. So the next we do is to join the intercepts or the points. You can use a freehand sketch. If you are conversant with the use of French curve, go ahead and use your French curve. Okay. All right, so this is how my curve looks like. Then the next thing we do is to proceed to solve the equations, other questions under here. We are solving D first. D actually came first before this C. This was supposed to be the C, but I skipped it, so I had to bring it under here. So we are given y equal to 2 minus x, and we are asked to use the same scale and the same axis to plot this graph. So this is a straight line graph. And whenever you have a straight line graph and the y-intercept is 0, we'll have value for x. If the x-intercept is 0, we have value for y. So I'll produce a table in this manner. This is x and y. When x is 0, we'll have value for y. And when y is 0, we'll have value for x. So let's plot it. For y, when y is equal to 0, I'll have 0 equal to 2 minus x. Make x the subject formula. If you bring it here, I'll have x to be equal to 2. So the value of x when y is 0 is 2. If x is 0, put it in this equation. I'll have y equal to 2 minus 0. That means my y will be equal to 2 also. So let's plot this graph on this same graph. So when my x is 0, this is 0. My y is 2. 2 is somewhere here. We count 0.5, 1. 1.52 to be here. Then when I have my y as 0, y is 0. My x is 2. So we plot, this is 2 here. This is 2. So we'll join it with a ruler, use a ruler and make a very straight line. And this is it. So we have gotten the two relations on the graph. Let's answer the next question. We are asked to use the graph and find the maximum value. The maximum value is the exact point where the parabola curved, or the turning point at this top. The parabola or the curve was moving up, and at some point here, it curved. So trace it to the y-axis. If you trace it to the y-axis, you get the value of y. The value of y at this position, this is 0.5, 1, 1.5. We have 1.5. Then the corresponding value of x, we are asked to get the corresponding value of x. At that point, we trace it down. The thing curved here. Get the value of y here, trace it down here, and get the value of x. So since here is 1, the interval here is 1. Let's get the little lines for x-axis. Most times they vary from y. So the interval here, or our scale, is 1, and the little line is 10. So divide 1 by 10, you will have 0.1. Since our little line is 0.1, we'll now count. This is 1, or rather 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So the corresponding value of x is 0.6. So we have x, y. These are the values of x and y at the turning points. And finally, we are asked to find the values of x equating the both equations we are given. Observe very well. This is the first equation and this is the second equation. So in order to find the roots of this equation, or the value of x from this equation, or to solve this equation using the graph, all you need to do is to find the intersection of the curve with the straight line. Okay, this is my curve and this is my straight line. They intercepted here and intercepted at this point. We are going to trace it down, and then this already at 2. So let's get this one. This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So we are getting the value of x as minus 0.7 because it's on the negative, or 2, which is at the positive. All right, we have one more question to go, which is question number 12. Let's solve it. The last question we have here is number 12. We are asked to find the values of x from this diagram, and then what percentage of students are offered mathematics. Then if a student is picked at random, what's the probability that that student offered economics or civic education? So let's start with the values of x and y. Observe this diagram very well. You discover that this 4x plus 3y is at 90 degrees in the sectors of this diagram. Look at this sign. It shows that